Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of proportionality, specifically how similar shapes are proportional, and we will do it in 5 minutes or less. So you might get a problem that looks something like this. You've got two different triangles, and it's going to say that triangle ABC is similar. It's going to have to definitely say that, similar to triangle DEF. And if we know those things, then we know that the corresponding sides are going to be proportional. But as you can tell, all they're telling you is that these two are similar. That means they're the exact same shape, the same proportions. They're just a little bit different size. So you can see our DEF is a little bit larger than the ABC, but it's so hard to see because DEF is rotated, or if you want to think that DEF is correct, you can say ABC is rotated. So if we're looking for some proportionalities, I would highly recommend, before you go any further, to go ahead and just draw one of these and shift it so that it looks the same orientation as the other. So I'm going to take this DEF and I'm just going to kind of rotate it this way because I want it to match what I've got right here. I'm not worried about the sides so much. I just need my, that's going to be close enough. So this big obtuse angle right here, that's going to be D. So if you're moving straight up right there, if you're going in this clockwise motion, it's going to be this E right here. That corresponds to that. And then you've got this F, which is the final one, and you see our shortest side here is DF, and our shortest side is DF. So I would highly suggest go ahead and just hand drawing one of them in a rotated state. Make sure, obviously, you're labeling the new picture correctly, because now we can kind of see some proportionality. So how could we write some proportions to show that these two shapes are similar? Well, let's just take the long diagonal of both of these right here, right? So we've got this BC. So I'm going to say this BC is proportional to this EF. So we're going to match from one shape to the other. Since I started with my smaller shape, I need to find another pair of sides that are proportional, but I also need to start from the smaller first. So I decided to do my smaller to my larger. So on this one I need to do my smaller first and my larger second. So let me pick up the smallest side right here. So I would do AC. So you notice how in my proportion, right, I've got my smaller side lengths listed first as my numerator. So the corresponding one would be this DF. So that could be a proportion that we could write. So what I'm doing is my proportion, if you're reading from top to bottom, I'm going from the small triangle to the large triangle, and I'm just finding a matching pair to make that. Now, another way you can make this proportion is you could go small over small, and you can make that proportional to large over large. So there's two different ways that you can make that. So let me show you what that looks like. So let me see. I'm going to do my this one that I haven't done right here. So I'm going to do this AB over my longest one. So my longest one is going to be BC. It's that diagonal. So I'm actually making a proportion with two side lengths within the same triangle. And as long as the other triangle is similar, which we've already established, you can make a proportion that's valid as long as you use the same corresponding side. So my AB was this one that's pointing up, and that's why it's very helpful to get your picture to orient the same way. So I'm going to match that AB with my DE, starting from my obtuse, moving up. Then I need to match this BC. So this BC over here is that long diagonal. So that's going to match with this EF right here. So if I could do that, there's many more that I can make, and obviously we can reverse these. There's nothing that says that we couldn't just flip the numerator and denominator. If you do that, you just got to make sure you do it on both sides, and that's how you use similar shapes to show proportionality.